I guess that's my cue, so we'll get started. Hi, everybody. I'm Jason Anderson. I am one of the leads on the Azure Blockchain engineering team. Specifically, I lead the Azure Blockchain Service team. But we have a lot of products that we've been working on. We had a lot of announcements this week. I'll talk about a couple of those. But let's jump right in. I want to set expectations first on what are we going to do today, because the title can be, you can only put so much in the title. And we kind of morphed it a little bit. But we're gonna go on a little bit of a journey here. I found through spending time at the booth this week that there are a lot of folks still that are learning about blockchain. It's a very nascent technology. It can be confusing. So I thought it'd be helpful to spend a good 10, 15 minutes talking about blockchain at a fundamental technology level, talk about some of the use cases, so folks can understand really what it is, the technology, how we're employing it at Microsoft, how it can be useful. Then I'm going to very quickly talk about Azure Blockchain Service to give you some context around why we built it, and the previous piece will help to tie that together. But then I want to jump into the Power Apps and the Power Automate aspect of this. I've been at Microsoft for a long time. I've been a PM for most of that. I haven't written code in a long time. And so when we started to go and work on blockchain, for me it was challenging to jump in and start writing apps to be able to leverage a blockchain. So when I got introduced to Power Apps, this light bulb came off in my head. I'm like, my God, anybody can do this. I can even do this. And so I got really excited about it. And what I thought would be helpful would be, I'll show you an example of a scenario with an existing Power App that one of my colleagues wrote. But then what we're going to do is we're going to spend 10, 15 minutes, and without any knowledge of blockchain, and with very little knowledge of Power Apps like myself, you'll be able to walk out of here building a Power App that connects to a blockchain. Okay? So let's go ahead and let's dig into it, because we have a lot to cover. So first, let's talk about blockchain. So blockchain is really about digitizing trust. And in fact, when we talk about blockchain to our enterprise customers, really the conversation, we try to focus more, or I should say less, on the technology and more on trying to achieve trust and transparency, whether that's for existing business processes, new scenarios that open up as a result of blockchain. But trust is the core fundamental aspect as to why blockchain is important and how it ties in. And as we know, trust is foundational to any industry, any business. We all have trust issues, or challenges, I should say, whether it's in regards to our customers, our partners that we work with that are a part of our business processes, and so forth. So it's not, you think of blockchain, the first thing that people think about is crypto and think about finance, which is a core element of the baseline of where the technology came from. But what's happened over the past, I'd say, year and a half is the crypto bubble kind of popped at the end of 2017, 2018. All the ICOs kind of died down, which was nice. That's when enterprises really started to see, hey, this technology actually can apply in multiple cases. And that's where, and we were working on it even prior to them, but that's where it comes in, and we'll talk about. So, current methods for building trust are frictionful by design, right? You either have intermediaries in place, auditing processes in place, and blockchain helps to remove a lot of that and save a lot of time in the long run. So let's talk about what blockchain is. And it's actually really simple. If you understand the core element of a database, which everybody here probably does, it's like a database. One core difference, though, is it really acts more like a ledger. Meaning blockchain in and of itself, as you probably are aware, is immutable by design, which means you can send a transaction to the blockchain and have it on the record, have it on the chain. But if you made a mistake or you want to correct that transaction, there's no update function, there's no delete function. You instead have to submit a corresponding correcting transaction. So it acts and is called in many cases a distributed ledger technology because it acts like a ledger. And the benefit of that immutability is you have a historical audit trail of all the actions that happen to state on the chain. So that's one important element to understand. The second element is that there is no single source of data in the blockchain. There's not a singleton database that's replicated out to everybody. Rather, everybody has a copy of the database, okay? And this is important because then you have control and visibility into the data directly. By the fact that it's immutable, you know that it's not been tampered with. But that then leads to the next question on, well, how do you update this thing? How do you send a transaction and ensure that it gets on if everybody has a copy of that database? And that's done through a process called network consensus. Now, network consensus happens on multiple different levels, and I'll talk about public and private blockchains in a minute, but let me just boil it down very simply. Network consensus for the blockchain protocols that we use in enterprise today have a couple of different protocols, and I'll talk about one. It's called Byzantine fault tolerance. And if you're familiar with the Byzantine problem, which has been around for a while, it applies directly in blockchain, meaning everybody has nodes on the network. Everybody processes transactions on the network. So if a transaction comes in, all of the nodes process that transaction. As long as 2/3 of the nodes approve that transaction, then it's committed to the chain. So up to 1/3 of the nodes can be considered faulty. Okay? And faulty could be that node is down, it's unreachable, or it could be that somebody's trying to forge a transaction. So you would need to get 1/3 of the network together to issue forged transactions in order to be able to break the network or to get that data in, which is very unlikely in a permission blockchain. In public blockchains like Bitcoin, as an example, it's a much higher bar because there's no trust with any other node on the network. So you have to orchestrate a 51% attack to be able to forge transactions and do a double spend, et cetera. And the process for actually being able to commit a transaction is very power intensive. In fact, every node that tries to mine a Bitcoin on the network, or they're not mining a Bitcoin, what they're doing is they're trying to effectively approve transactions. Everybody approves a transaction, but then they go into a race. And the race is to try to solve a cryptographic puzzle. And the cryptographic puzzle they have to solve has to do with creating a hash of a certain length that has certain characteristics. And the only way to do that is through a brute force attack. And Bitcoin is designed natively such that the more coins that are mined over time, the harder that puzzle gets, the longer that hash becomes. So that's why the power problem with proof of work, which is that consensus protocol, is emerging with Bitcoin and emerging with Ethereum public networks. But what we're talking about is something a little bit different. And so I'll get into that. So there's two types of networks. There's public blockchain networks like Bitcoin that I just talked about, and Ethereum as a public network, and there's a whole host of others that exist. And those are primarily crypto-based networks. Bitcoin's a very simple ledger network where it's really transferring assets of Bitcoins from one person to another, and that's about it. You can do some other interesting things on it. In fact, we anchor a lot of our digital identity work we're doing on the Bitcoin network, but I'm not going to spend time on that. That could take another hour. But it's very, very simple. Ethereum is a little bit different. Ethereum has the context of what's called a smart contract. Basically, why can't I execute a state machine on the network itself to be able to decide if I'm transferring a Bitcoin or not? I might say, hey, if the weather is going to be above 80 degrees, I'll transfer a Bitcoin to you. But if it's below, I'll transfer a Bitcoin to you. So it's a simple if then else. You can encode that as a smart contract on the network. That itself is also immutable. So that way when that condition occurs, you can branch out and do one or two of the options. And that's super powerful. And so what that has led to an emergence of are what are called permission blockchain networks, of which Ethereum is one of those. There's also Hyperledger Fabric, R3 Corda, and several others as well that exist. And so what enterprises saw is like the fact that they can encode logic, business logic on a blockchain network is very powerful. But then they also had the need for privacy. So Bitcoin and Ethereum in general are by nature anonymous. That's one of the power of cryptocurrency is it removes the traceability, if you will, which is why a lot of cryptocurrencies got a very bad rap early on because you had gangs and drug dealers and so on that were using it for anonymity purposes. But for Ethereum in the permission space, you can actually set up permissioning. For example, I may not want one party to see that I transferred another party money or an asset of some sort. So that piece exists, and it's one of the core components. But the key thing for a permission network is I can create my own network, and I can add selected parties to be a part of that network. And that comes across if I wanted to do a business process where I have shared parties, like a supply chain. And I'll walk through an example of that. Now, blockchain is not a panacea. It doesn't replace databases. In fact, it very rarely does. And so there's a couple of key questions you ask yourself when you're evaluating whether a blockchain solution is appropriate for you or not. And the first one is what I just mentioned about, do you have a business process that crosses a trust boundary of some sort? And if you do, cross that trust boundary, are those two parties or multiple parties working off the same set of data? If they are, well, who owns that data? Who's controlling it? Is it one of those parties? Is it a third-party intermediary that you pay to manage it? How do you manage auditing to make sure that that data is actually accurate? You probably have some low-value, high manual processes to do that. So if you can answer yes to these questions, then blockchain may be a solution for your business process. May not, but it may be. So let's walk into a scenario, and let's talk about a food contamination scenario. I should change this to romaine lettuce, given what's been going on over the past year or so, but milk's a good example of one to illustrate. So let's imagine that you go to the store, you buy some milk, you go home, you drink it, you get really, really ill. Well, the problem is, who's at fault in that case? Was it the store's fault? Was it one of the transport carriers' fault? A warehouse that didn't keep the temperature? You don't know. You can't trace it. So we looked at a scenario where we encoded on a blockchain a refrigerated transport case. So this is what the chain looks like. You've got a food processor who returns that milk from the dairy farmer into homogenized milk or yogurt or whatever. Then a transport carrier takes it to a warehouse. Another transport carrier then delivers it to a store, Fred Meyer or QFC or name your favorite store. And then eventually it goes home to you. So if you encode this supply chain or elements of it on a blockchain and institute a smart contract, as I mentioned before, and the smart contract in this case is very simple. So what happens is the milk container, the milk product itself, has an IoT, tamper-proof IoT temperature-sensitive device that's attached to it and sends data to the ledger, real time, of the data characteristics or the temperature characteristics and humidity characteristics of the milk at that time. So the smart contract encodes that simple state logic. So let's walk through the flow and see what happens. So the food processor at the origin is at 8C, 60% humidity, so he's okay. Handed it off to the carrier, carrier 1. Same thing, was able to keep it within tolerance. He handed it off to then the warehouse. The warehouse kept it at 9C. Now what's happening here is every time that milk transfers hands, it's actually changing custody, right? And so by putting it on a blockchain as well, you effectively tokenize that milk. You're transferring it. You say at that point, I'm the food processor, I am on the blockchain giving you these tokens that represent this milk. You now own custody of it. Anything that happens between you and the next stop is your responsibility. And it's encoded on the blockchain so you can go back in historicity, you can look at it and see that what happened during those times. So let's look at what happened to carrier 2. So carrier 2, when he was driving to his destination, realized he left the diesel cap off of the fuel tank, spilled a lot of his fuel along the way. Doesn't think he has enough fuel to get to the store. If he stops and gets more fuel, he's going to get in trouble with his boss. So he thinks, I'm going to turn the chiller off now, and then I'm going to coast in, and right before I get there, I'll turn it back on, so it'll be cold again. Nobody will know that better, right? Well, the blockchain knows better. So what happens is that event fires in the blockchain, so it's looking for that event. So what happens at that point is he's violated the state of the smart contract, and parties that are able to see that data, in this case the retail store, can actually get an alert saying, hey, this milk that's coming to you is bad, don't accept it. So they can then cancel having that come in, and then we never have a food contamination problem. That gets to consumers, okay? Now, important to this as well is this then creates a record of that transport carrier in terms of their ability to handle the product appropriately. If they do this multiple times, you have a record of it, you could cancel their contract, give them a penalty, et cetera. So this is just one case. We see supply chain is very common, we see healthcare very common, financial, it applies across all industries. But the challenge that we've run into over the past few years is building this infrastructure is really hard. In fact, we had customers that came to us early saying, Microsoft, help us build this. We want to prototype some scenarios of blockchain. And in many cases, they would hire an SI to help them. They would spend $500,000, spend 6 months, and they would end up with a screen of scrolling text. And their CEO would say, well, what am I looking at, the Matrix or a demo? I don't understand this. No more funding for you. So we thought if we could do as much work as possible to try to lower the bar to get to a POC, that would be fantastic. And that's what we're going to show you today is we're going from 5 months, $500,000, down to a POC that you can build within hours, right, including all the logic. So we introduced Azure Blockchain Service. It's a managed service. We introduced this back at Build last year. the best way to think about Azure Blockchain Service is similar to what we did with SQL Server. We took SQL Server and we made a great product in Azure called SQL Database. And I no longer have to be a DBA to set it up. As a developer, I can click deploy. I have an endpoint now that I can develop against. It's that simple. Azure Blockchain Service is the same way. We will stand up a blockchain network for you, give you the ability to then build a consortium, invite others to join that network. They could even be in other Azure subscriptions and eventually be outside of Azure even to do that. So it's based off of, we're using the Ethereum, the Quorum version of the Ethereum ledger. Quorum is a product made by JP Chase, believe it or not, a bank, that specialized in creating a permissioned blockchain. Now, in order to make, there's multiple of these protocols that exist, but there is a body called the Enterprise Ethereum Alliance that effectively puts out a specification. So if anybody wants to create a enterprise-grade Ethereum ledger, they should be EEA compliant. If they are, then you know that you could move from one Ethereum ledger to another relatively easily. So we've partnered with JP Chase. We've offered that product inside of Azure Blockchain Service. We decided specifically not to create Microsoft Ledger Server 2019 and take an open source approach and use where customers are at today. But then customers told us they wanted more than just Quorum. So we've also added, a couple weeks ago, we've added Core to Enterprise by a company called R3. It's another ledger. It's not based on Ethereum. It's a different technology. But it serves the same purposes and is a distributed ledger technology. Customers are using it, so we thought, let's adopt that. So now we talked about Blockchain 101. Hopefully that was helpful from a grounding perspective. But then the next question that comes up is, great, I understand blockchain, but like a database, how do I get data into it? How do I get data out of it? Right? That's the hard question. So here's a solution architecture. You can use Azure Blockchain Service, a blockchain data manager, and you can build a transaction manager using logic apps, using Service Bus to ingest data in from IoT, other apps, et cetera, expend it out to Event Grid, and then connect into Flow, Power Apps, et cetera. Did you catch all that? That's really good if you're an advanced developer, and that's a legitimate solution diagram we have on our Azure.com page. Don't get me wrong. I'm not making light of it. But there's a much easier way to get started because, again, where the majority of customers are today is they're trying to identify, do I have a use case? If I have a use case, before I spend a ton of money, I want to build a proof of concept, and I want to do that quickly, right? So that's what we're going to focus on. So how do you make it easier? One of the areas that we invested in early on is we worked with the Microsoft Power Apps, and at the time, the Flow team, now Power Automate team, to create Ethereum connectors for Power Apps and for Power Automate. And these Ethereum connectors make it such that you don't have to write the custom logic in between to connect common services together. This gives you an input and output mechanism with low to no code. And I've been hearing about this as a part of the team. We're working on a lot of stuff. I have a different part of the team that's built this stuff and worked together, thought it was great. But until I started using it, I was blown away at how easy it is. So let's jump in. The first thing I wanted to show you, though, is I want to do a demo of a scenario using Power Apps. I can switch over here. Okay. So let's look at a trade agreement scenario, okay? Let's say you're an airplane manufacturer, you could be Boeing, Airbus, or whatever. And this is a very simplistic scenario, so bear with me, but I want to point out a couple points about it. If I'm an airplane manufacturer, I don't make the engines, I buy them from GE or Rolls-Royce or somewhere else. The same goes for wings as well, and a bunch of other components in an airplane. Boeing doesn't make all these things from scratch. So they have trade agreements with all of these different suppliers, right? So I'm Boeing. And so I've got a wing price from my wing supplier of $1,000. It's a pretty cheap wing. Now, the way this is set up is my supplier has effectively, in my trade agreement with them, has given me the ability to have volume discounts, effectively. So if I buy a certain volume, then I get a scaling discount. In this case, again, example purposes, if I buy 10 wings, or over 10 wings, I get a 5% discount, over 20, 10%, and so forth. So if I go to my purchase order here, and we're doing wings, units, if I say 10, and I refresh this, this is all backed by, this is connected to Azure Blockchain Service with smart contracts that are employing the logic on those trade agreements, specifically the discounting in this case. So I did the simple calculation. I don't get a discount, but you know what? let's go for 12 wings because nobody's going to buy 11. So let's refresh that. And you're going to see that the state's been updated. So it's simple logic. This is simple math, right? What's important about this is that, number one, I don't have to have two separate systems between the supplier and the airplane manufacturer to integrate. The data itself is on the blockchain and it's shared. You can have your own disparate systems to access that data. But another important element comes as a part of this. Let's send that purchase order over. Okay. Now let's take a look at the engine side of the business. Okay. Engines are a bit more expensive than wings. In this case, they're twice as much. But the same component holds true that I'm going to have a trade agreement with them. And it's not going to be the same that I would have with the wing manufacturer. There's going to be different volume discounts and things involved, et cetera. In this case, 5 engines, 5%, 10, 8%, et cetera. And the same logic applies here, right? So let's do 6 engines, just get our discount. Now, every time I'm sending a purchase order over, in this case, that's being encoded on the chain. So there's that historical account that purchase order was there. It's not locked in a particular system that somebody else has access to or 2 separate disparate systems. It's in a source of truth. Now, but what also is important here is that the engine manufacturer, I can see as Boeing, I can see what my trade agreements are, what my discounts are for each of my suppliers, but those suppliers should not be able to see their discounts to one another. So this might be even more applicable if I was doing engines with GE and Rolls-Royce. I might have different trade agreements. In fact, I probably do, with different kind of discounting associated with it. But this was all built by one of my cloud solution architects in a matter of hours, building the smart contracts, writing the Power App for it, to just demo how this can be done. And really, the magic here is not the app and the interface, obviously. It's more the back-end logic and how it's decentralized, which is where blockchain comes in. Okay, so now let's get to the fun part. Let's build an app, okay? So where I'm going to start is in Visual Studio Code. Now, don't freak out. We're not going to write any code. But with Visual Studio Code, what we've done is we've created a new extension. It's called the Azure Blockchain Development Kit for Ethereum. And what it does effectively is there are several tools that are used to compile and deploy smart contracts on Ethereum. We effectively leverage those. We think of us as a CLI wrapper in VS Code. So we can do right-click deploy type functionality, as well as a whole host of other things. But let's go ahead and get to the quick part here. So you also notice that I have it installed. So if I go to the Azure Blockchain piece here, and this is refreshing right now, I can connect to multiple networks here. So I can connect to Azure Blockchain Service. So I'm already connected to my service. If I wanted to, I can actually create a network here. I can create Azure Blockchain Service from here. I don't have to go to the portal to do it. I can just follow through the prompts here and create the service from VS Code if I want to stay in the IDE. But I also have the ability to deploy this locally. So if I don't want to deploy the service, if I'm playing around, which is what most of you are doing, and don't want to pay for an Azure resource, we'll install a local environment for you. Actually, it's already installed. Hook it up and enable it. So you do local service, it'll do it that way. We have partners we work with like Infura, so I can use an Infura service if I want. I can also deploy it to testnet and mainnet if I want to. But I'm already connected, so we'll skip that. But what I'm going to do now is in fact, what I should do first, let's switch to, let me show you what we're going to build. If I can just find out where the app went. Oh, there it is. Okay. So I've got a Power App that I've created on my phone. It's this one right here, so let's open it up. So this is a simple get set application. It's a typical hello world application that we're going to do. And all that I'm going to do is I'm going to send a message. Hi, everyone. I'm going to send that to the blockchain. So what's happening now, it's sending this transaction is being mined. It's being put on the chain. And then when it's done, it's going to send me back a transaction hash, which is effectively confirmation that the transaction has been put on the chain. And this takes a few seconds. So there's our hash. So now I'm just going to do a get message from blockchain, which is going to go back and call that function and grab the data, and there's hi, everyone. It's a very simple application, but we're going to build this right now. No code necessary. You don't need to touch a line of Solidity code, which is the Ethereum smart contract language. So let's go ahead and do that. So the first thing I'm going to do is I'm going to pull down our sample from the Azure Blockchain Development Kit. So if I go to View, Command Palette, there's a whole bunch of Azure Blockchain, if I spell it right, commands that are here that I can do. But we're going to do new Solidity project. We're going to do a new basic project. Truffle is one of our partners that we work with. They provide a bunch of what they call Truffle boxes, which are a bunch of samples and things that go together for scenarios. So that's pretty useful as well when you get a little bit more advanced. But we'll do a basic project, which is going to pull down this Hello Blockchain application. So it's going to go ahead and effectively go up to our GitHub repo. It's going to pull down those assets. But what it's also doing is it's building out the scaffolding necessary to deploy the contract. So all of the Truffle configuration files that you would need to do that. It's also going to build up a structure if you wanted to open source this. So you get a change log, contribution file, license, and a bunch of other stuff that's necessary here that you don't have to worry about. Okay, so it's still creating that project, but our contracts are there. So let's go ahead and take a look at those real quick. So here's the application, the Hello Blockchain Solidity file specifically that we're going to work with today. So let me bring this down. So this is a very simple app. There's basically two functions that we're doing. We're doing a send request and a send response. And in fact, for this demo, we're just going to do the send request. We're going to send a request to the chain like I showed you, and we're just going to pull that value back out. But we don't need to worry about that. We're not touching this. Now that this is all done, what I can do here is I can right-click, and now I can build the contract. This is going to create the what's called the ABI file, basically the JSON file that describes the contract itself. So we'll let that do that, and we'll go back to where we were before. Okay. So let's go to Power Apps. So I've started a brand new Canvas app, nothing done yet. Let's go ahead and recreate what I showed you earlier. So we're going to start with a label. Now we need an input box. And I want that to be blank by default. Okay, and now we need a button. Okay. Now, what we need to add is another label. We're going to put our transaction hash information in. So this is transaction hash, and then one more label that's going to store that value. Okay. Now we're almost done. So now what we're going to do is we're going to do another button. This will be our get message. And then we need a label to store that. Okay, we've got all the controls that we need on our app now. Now let's go ahead and plumb this up. Before we plumb it up, let's go back to Visual Studio Code. We've built that contract out, and it created this build folder, and it created these two JSON files. So this migration Solidity file program is a component needed to migrate elements to the chain. We don't have to worry about that. So Hello Blockchain is the ABI file that we need, okay? So that's all there. Now what we need to do is we need to deploy this to the blockchain. So I'm going to go ahead and right-click on the contract. I'm going to deploy it. It's going to ask me where I want to deploy it, so I'm going to deploy it to my Azure Blockchain Service. Now it's asking for a mnemonic. So basically, I need a private key to sign this transaction. It's going to effectively generate one for me, or I can use an existing one. So I'll use one that I've already generated. And that is now deploying. Okay. Great. So while that's deploying, what we need to do now on this button is we need to give it an action. So let's go ahead and go to action. And now we're going to go to Power Automate Flows. All right, I got a bunch of flows here, but we're going to go ahead and create a new one. And we're going to do a simple Power Apps button here. We'll call this send message 2. And create a new step. Okay, so now we're going to search for the Ethereum connector. There it is. Okay, now I got multiple options down here. What we're going to do is we're going to execute that function, that send request function. So we're executing a smart contract function. So we'll click on that. And now it's asking for a bunch of scary stuff. So the ABI, the contract address, et cetera. So let's go back to VS Code. We should be deployed by now. Yep, we're deployed. So if I scroll up a little bit, we can see here, hello blockchain, it's been deployed. Here's the contract address. So that's what we just saw previously. So I'm going to copy the contract address. This is exactly what it sounds like. This is going to tell our application where the contract is to be able to reference it. So since contracts, like state on a ledger, are immutable, I can't change this contract once I've deployed it. I have to deploy a new contract instead. And I would just point my application to the new contract address if I were to do that. So let's put the contract address in. That is not what I want. Okay, now we need the ABI. So let's go back. And if I just right-click on, the JSON file is the ABI file. If I just right-click on it, I can say copy contract ABI. So now that's in my buffer. I can paste that here. There's the ABI. This describes the contract. This is new as of today. Wow. Okay, so now what contract function do we want to grab? So it's going to grab this from the ABI. So I drop down here. I can do send request. Okay. And then what's the request message we want to send? Well, we don't want to enter it here. We want to ask in Power Apps. So we're going to say ask in Power Apps. Okay. Now we're going to do one more. We need to go to advanced section. So one thing I didn't talk about is gas price. So gas is a concept in Ethereum. It actually costs something. So this avoids contracts from running endlessly, avoids endless loops. So if you assign so much gas, there's a gas limit. But we don't use gas in Azure Blockchain Service. That's not necessary, but I have to set this for other reasons. We'll fix that later. Okay, so I've got that done. So now we're going to add one more simple step. We're going to do a respond. And we want to do respond in Power Apps or Flow. And this is where we're going to get the message. Or excuse me, we're going to get the hash. We're going to call hash, and the value we want is transaction hash. Simple. Okay, let's save that. Okay, let's go back to our app. And we should see this populate here in a couple of seconds. There it is, send message 2. I'm going to add that, take a drink because this takes a few seconds. Okay, great, we've added in there. Now, let's go ahead, and this is the code we have to do, minor stuff. So first thing we need to do is we need to set the variable to store the hash. So we're going to set, we're going to call it vhash, and then we're going to run that flow, and we're going to shove it into send, what do we call this? It's message input label. Yep. Message input.text. Okay. And then, yeah, that's good. Okay, so we're good there. Why is it complaining? Okay, help me out, guys. I'm missing a parenth. That's right. Always in demos. Forget stupid things like that. Okay, now we're good. Thank you, guys. Okay, now in our text, we're just going to grab vhash. And then there's hash that we declared in the previous function. Okay, great. So we've got that taken care of. Let's go to the get message now. We're going to do a flow for that. And we're going to create a flow there. It's almost identical of what we're going to do. It's actually a little bit simpler. So it's going to be a Power Apps button again. Look for the Ethereum connector. Now this time, we're not executing a smart contract function. We're literally just querying the current function that we want to grab. So we're going to query the smart contract function. Again, we need the smart contract address. And we need the ABI. Go back here, right click. And the function that we're grabbing is the request message. Okay, and now we're going to do a respond to get our message. No, we're not doing that. We are, wait a minute. Yep, that's what we're doing. Okay, so add an output. We're going to call this message. And then we just want the function output from the Ethereum connector. Okay, so let's save that. Okay, let's go back to here. Now we were going to do get message to, should show up here. There it is. Take another drink. I don't know why this takes so long. All right. Now, similar as before, we're going to go ahead and declare a variable. Put the proper number of parents this time. That's all we need. And then in text, the message.message. Okay, and that's it. Fingers crossed it works. Let's send that off to the blockchain universe, get our transaction hash back. There it is, and get message. There we go. So, as you can see, this is a very simplistic demo. Thanks for the applause, but I think a fourth grader could do this, or a third grader. But this was exciting to me because now I can certainly do a lot more with this. And my thought was, my gosh, I think this could be really helpful because blockchain can be intimidating by itself. Again, our goal is to provide as much assets as possible, whether through connectors and samples and integration with VS Code, that you did not have to touch a line of blockchain code. It was just copy and paste, minor coding and Power Apps. But the power of what you can do here is incredible. Again, the key thing is being able to build a proof of concept in literally hours versus months and at almost zero cost. So having said that, we have Azure Blockchain Service. We're trying to make this easy, as I said. The Azure Blockchain Development Kit, which we're going to continue to add more functionality to. One of the things that I did not show you, because it's not there yet, is we just wrote an app to be able to send and receive that message. We're going to build in a React UI into VS Code so you could just do it directly from there. Whatever functions you declare would show up in VS Code, and you can actually exercise your app from there just to make sure it's working. So things like that are going to be coming real soon. But the magic here is being able to use Power Automate and Power Apps to do this so quickly was just a joy. So having said that, one of the things that we've tried to do, as you can tell, is and I didn't talk about a lot of our other announcements. In fact, let me just quickly switch back because there's a bunch of other stuff that we're doing. We announced a new service this week called Azure Blockchain Tokens. So when I talked about that refrigerated supply chain scenario where we're changing custody, we're effectively transferring a tokenized asset, crates of milk, from one party to another, and then they hold custody and responsibility for that asset. Azure Blockchain Tokens is a new service that we have in private preview right now that effectively lets you define the characteristics of the token. There's an initiative that's been put together by a lot of the blockchain community and large companies like Microsoft called the Token Taxonomy Initiative, which is effectively putting together a spec to define what the common characteristics of a token are. The reason this is important is, number one, we talked about a permission blockchain, but there's scenarios where two permission blockchains or even a permission blockchain and a public blockchain can intersect. For example, in a trade agreement scenario, if I wanted to pay using crypto, I could send that PO and then have it connect to the Ethereum public blockchain and pay for it in Ether, or Bitcoin and pay for it in Bitcoin. So connecting those chains together is an example. So having a common token definition can then span different types of not only applications, but different chains as well. So Azure Blockchain Services or Azure Blockchain Tokens, is in preview to do that. And there's a bunch of other stuff in the pike that's coming as well, whether it's including more ledgers in Azure Blockchain Service, the development kit, and other services such as this. We're also not alone in this journey. We've worked closely with a lot of partners. Some of these partners are blockchain-specific companies like Envision Blockchain and Consensus. Others are large companies that you know like Infosys and Ernst & Young. And we've got a large list of customers that are already using these assets today in production. Xbox, and you see the logos here, but let me talk about the Xbox one real quick. It's really interesting. We're using it for royalty payment visibility to our publishers. So when you buy a game on the Xbox store, we owe Electronic Arts or Ubisoft a royalty for that. And the calculation of that royalty is based off of a whole bunch of different factors. Was there a sale going on? Do you have credits, et cetera? Our previous process was we would batch all that up and run a batch job at the end of the month that would calculate the royalties for all of those publishers. We'd send them an Excel file. They would look at it and say, this doesn't seem right, and they would do their own calculations. Then we'd go into arbitration, and it was just a big mess. So instead, we moved that to a blockchain, and that gave us a couple of things. Number one, the publishers could receive that data now instantly rather than waiting 45 days because the calculation of the royalties were all encoded in smart contracts. Okay, that's one. Number two, if they had questions about the royalty payments, since they are on that blockchain network and they have a node, they can inspect the contract and see when it ran and expect the state machine. So there was no more arbitration that needs to happen to come back to Microsoft. They can look at it and then understand it. If we need to change the smart contract logic, then we can redeploy into a contract for that. So it's significantly simplified and really alleviated a pain point, mostly for our publishers, to get that data quickly and be able to use quickly. So a lot of scenarios like that that are in place. I demoed a scenario or I had a partner at GE demoed a scenario yesterday where they're using it for part genealogy for aircraft parts. So think of it as Carfax for airplanes. After so many hours, an engine needs to be torn down and rebuilt effectively. Those parts go off to repair shops. People lose paperwork. They lose the paperwork. FAA says the part's garbage. You got to throw it away. So a lot of scenarios where blockchain really helps to alleviate those scenarios. So with that, I'm going to wrap up. Here's a quick slide on other sessions that are blockchain related. Some of them have already happened, obviously, but they'll be available to download later. Let's take a look at that. But another useful slide might be the resources we have if you want to take a look at some of the documentation we have for the new services we announced, samples, link to the VS Code extension, et cetera, et cetera. So I just want to, again, thank you for your time and your patience as I did a demo. Hopefully it was good to give us an evaluation. But again, thank you very much for your time. I appreciate it.